Hey everybody, it is time for another run through. This program is going to be a little different than the previous ones because today we're going to be talking about functions. It can also be called methods depending on the language you're running with. But what essentially a function is, it is a bit of code you place somewhere else. You give it a name, and then you just use that name to run it whenever you want to use it. Now, the main that we have here is a function itself. In fact, it's structured exactly the same way we're going to be structuring some other stuff. The difference is the main is the one thing that runs kind of implicitly. No matter what I do, when I hit this button to run this program, it compiles, it runs whatever's in the main. Now, if I were to go up here, and it doesn't really particularly matter whether I go below or above, but I kind of prefer above. It's just my personal preference. If I were to say void, let's just say print something, right? I'm going to explain what each of these little bits does. But see out uh, fuzzy pickles. There. Now this is a function. The first part I give is essentially what's going to come out of this function when it runs. Void means nothing's going to come out of it. It means I can give it some stuff, which I'll do in just a bit. I can give it items like integers or doubles or strings or whatever objects. This is what comes out. And in this case, nothing comes out. Now, in the main, you notice it says int. Well, technically, we could have an int there. It's kind of implicitly there in C++, which is why it doesn't crash. But in a function, if you didn't have some sort of return in it, once we get to that, you'll see, it kind of will give you some difficulties. Now, I made this function, and it's supposed to print fuzzy pickles. There we go. If I were to run this, you're going to find that essentially nothing happens. And the reason for that is, well, I didn't tell it to do anything. I told you before that the main is what runs whenever we run our program. This is not in the main. It is a separate function. Now, if I want it to run, I can come down here and do this. Print. Now, if I run it now, we'll take a quick look. And check it out. Fuzzy pickles. Now, what this is called is a method call or function call. So I call the function by basically invoking its name. Now, this is what type it's going to give back. This is the name right here. And in parentheses is what you plan to give it, so it can do what it needs to do. Maybe I need to give it a number so it can do some math. Maybe I need to give it a location or, XY coordinate or something like that, because I'm displaying something on a map or something. Maybe I'm trying to calculate damage that some character is doing to an enemy, and this whole function is basically designed to do that. A function can have one line or thousands of lines even. And the nice thing about a function is, well, there's several nice things, but one nice thing is, even if it does have thousands of lines of code, I just need the one to run it. Just need to call its name. You see if I click on it, you see it kind of highlights there. So a couple of purposes of a function. One, of course, is to separate the code out a little bit. So if I need to do something, fairly sizable, let's go back to my game example. Whenever you hit tab or escape or M or whatever, a map comes up, right? So you'll do that repeatedly throughout the entire game. Now, I would not want to have that code like copied and pasted. Let's say it's several hundred lines of code. I wouldn't want to copy and paste that several hundred lines of code over and over and over again in different parts of the main, where I might call it or might run it. Maybe there's some point in the game where it pops up the map to let you know what the next objective is or something like that. And I would not want to have to just 700 lines, 700 lines, 700 lines in different places over and over again. So what I can do is put that into a function and then just say map or display map or whatever I want to call it. One line will run those 700. I don't have to repeat them over and over again. This, of course, saves you space. It also allows you to separate the code out so it's a little more organized. If something breaks, well, generally it'll tell you where it broke, but sometimes it's not 100% helpful as to where your error is or what it is. So this is where having several functions, and every program, every basic building block of a program is going to have some functions. It makes it easier to find those errors. So if I try to display the map and all of a sudden my game crashes, well, I know the error or the issue must be in display map. It allows you to kind of hone in on where those mistakes might be. And of course, it saves space by separating it out. I use one line to call hundreds or thousands. And again, it's also better organized. So those are your three kind of major points as to the purpose of a function. Now, a void just simply displays something on the screen. It could do some math and stuff, but it might just print that answer. If I want to get something back from it, that's where I define, when I make this method declaration, I define what it's going to give back, whether that's a double or a string or even a Boolean or something. Maybe it returns, I don't know, a true false if like somebody has won a game or something. Win. So this would be basically, it would have to return a true false. Did the person win? Did the player win? That sort of thing. So let's make one here that simply just void print total int in 1 comma int in 2. And all I'm going to do is int total equals in 1 plus in 2. And I'll just print it out. Cout in 1 plus in 2 equals total. There we go. So in this case, print total, since it's just printing it, I can go down here and call it print total, and I have to give it 2 numbers. If I just do this, it's going to give me an error. Too few arguments in function call. So I'm supposed to give it 2 integers. So in this case, I'll give it, a 30, comma, 40. So when it's up here, this is what's called a method parameter. It means I'm setting up, when I make my method, method function parameter, this is what I want to give it. Down here is what's called an argument. Sometimes those concepts or terms are interchangeable, but usually this is called an argument. I'm passing an argument of 30 up here. So when I run this, "30 plus 40 equals 70." And I could have done well with a little space there, I suppose. There we go. 30 plus 40 equals 70. So I pass the 30 up, and it gets plugged into here. I pass the 40 up. It gets plugged into here. So N1 is 30, N2 is 40. So the total is 30 plus 40, which is 70. I print 30, the plus sign, 40 equals, and then right here would be that 70, which is stored in total. Now, if I wanted to get an actual value back, I'll call it get total. Make a little comment there. Okay. So the difference between the first one and what I'm making now is that first one, it'll print that number on the screen, which is great. But what if I need that number for something? What if I, need that number in order to, I don't know, do some math for something else? This is how much damage something takes. I need that the actual calculated number back, so I can plug it into something else so it can lose health or something. I need that math for something. Well, in this first case, I'm not going to get the math because it's a void. It basically doesn't give me anything back. Now, I could make a global variable up here or something and change that. That's one way to kind of get around it. The usual way is to have it return that value. So return in1 plus in2 is the shortest path there. I could also technically come up here and just say, total equals in1 plus in2, return total. So I could do that way if I wanted to. Now, if I were to do this, get total, 100, 100. All right, that should be 200, I think we all agree, right? And you don't actually have to have the return 0, but it's going to automatically do that unless you say otherwise. So in this case, 200, right? And if I run this, take a quick look, I don't see a 200. And there's a reason for that. In this case, there's a print statement, right, for these two. I print out, see out this, see out that. There is no see out for this. When this runs, it comes up here and passes the numbers 30, 40, and return basically sends the answer back, and this line becomes that. What I mean by becomes that, it means this. So I run it, and now you'll see 200. And the reason you see it now is because I've stored it somewhere. The way I usually demonstrate it in class is, think of it as me throwing some baseballs or tennis balls at somebody. If you're a function, I throw these two balls with numbers on them to you. You do your math, and in this case, you get a total, write it on a different ball, and show it to everyone in class. And then you throw it in the trash. That's what happens here. Now in this case, I give you those two balls, you do your totaling, and you throw that ball back to me. Now, in the first case where I didn't have this part, you threw it back to me and I just didn't bother to catch it. It just hit the floor and rolled off into the distance. We can't use it because we're not catching that result. In this case, and I'm actually catching it with basically my own little catcher's mitt that I made, this total. So when this value comes back, this is 200. It just says int total equals 200. So when I printed it, you saw the 200 pop up on the screen because this caught the numbers that were coming back. Now I can make this as many things as I want. I could come up here and even have different things if I wanted to, like that. And that's perfectly fine. A lot of people get stuck in the fact that all of these up here have to be the same. They don't. They can be whatever you want them to be. Now the return has to be whatever this is. So some people think they can return like several things at once. You can only return one thing. Now I could make an array and return that array, which has several numbers in it, but it's still technically one thing as far as the program is concerned. So in that case, I can do it that way. But if I had like several integers, I can only return one at a time. And once I use this return, like if I want to come down here and just say cout meh, and I were to run this. Now, some programs like Java, for example, will give you an error here. Other programs, Python, C++, will just ignore that completely. Notice there is no meh. And the reason for that is this. We come over here. Well, return leaves this function and comes back here. Well, that means this can never happen. Nothing after return can happen. Now, if I put stuff before that, it'll do all that, but as soon as it finds a return statement, it comes back and plugs it into here. And that's your basic rundown of how functions work. Now we can have, like I said, void, int, or other different kinds we need. It just depends on what we're trying to do. And then I just simply have to call them, is what this is, to run them. Or in this case, since it's a return, I need to have something catch that value. Now I could also put this into a print statement, because it's just going to become 200 once I run it. So I could say cout doot doot, and then put that there, and it would still give me 200. The difference between that and this is, well, the difference between printing something on the screen and me saving it so I can do something else with it. With this, I can print it, or I can pass it to another function, which is, again, what the word means when I'm trying to give it up here. I pass that argument here. Now, that's your rough rundown of functions. As usual, if you have any questions, comments, or concerns, just let me know.